Morning to all. In this video, we will discuss about the next topic of conics, that is hyperbola. So what is a cone? A cone has circular base at its bottom and a point on its top. A line which joins the top point, that is called vertex, and center point of the base circle is called axis or altitude. So we can get various types of conics based on the position of cutting planes with respect to the axis. Suppose if the cutting plane is perpendicular to the axis, that is parallel to its base circle, then we can get circle. If it is slightly inclined to axis, then we can get ellipse. So here we are going to discuss about hyperbola. If the section obtained by a right circular cone by a section plane parallel to the axis of the cone and perpendicular to the basis, then we can get hyperbola. So hyperbola cutting plane is exactly parallel to the axis. So what is eccentricity? So eccentricity is the ratio between distance of moving point from focus and distance of moving point from directrix. So the ratio is less than 1, then we can get ellipse. If it is equal to 1, then we can get parabola. If the eccentricity ratio is greater than 1, then we can get the hyperbola curve. When we can get the eccentricity ratio is greater than 1, that is a distance of moving point from focus is longer than the distance of moving point from directrix. So whenever we can get eccentricity value is greater than 1, then we can get a hyperbola curve. So as we discussed earlier, F is a focus point, D is the vertex point, and AB is the directrix, and the line CE perpendicular to AB is axis. So based on the distance of F and D, we can get various curves. In hyperbola curve, the FD value is greater than CD value. FD value is greater than CD value. What is hyperbola? A hyperbola is defined as the locus of a point moving in a plane in such a way that difference between its distance from two fixed points called foci is always a constant. Next, we will discuss about a sample problem. So draw a hyperbola. The distance between the focus and the directrix is 35 mm and eccentricity is 4 by 3. Here the eccentricity value is 4 by 3, that is it is greater than 1. So whenever the eccentricity value is greater than 1, we can get hyperbola curve. So in this video we can see the procedure to draw the hyperbola curve. First, we have to draw a line AB, that is vertical line, which is called directrix. Next, draw a line perpendicular to AB, that is called axis. The line should pass through point CE. Next, locate the focus point F, that is the distance CF should be 35 mm. Distance CF should be 35 mm. Next, divide the line CF into 7 equal parts. That is E equal to 4 by 3. That is 4 by 3 means DF by DC equal to 4 by 3. CF equal to DF plus DC equal to 4 plus 3 equal to 7. Hence, we are dividing the CF line into 7 equal parts. Next, draw a perpendicular line DG at D such that DG is equal to DF. Next, join the line C and G. Extend the line up to a certain limit. In this, the triangle DCG, DG by DC equal to DF by DC equal to 4 by 3. Next, mark a point 1 on the axis and draw a perpendicular line through 1 to intersect 1 dash on the inclined line. With focus F as a center and the length 1 dash as radius, draw an arc cutting the line 1 dash at points 1 1 and 1 1 dash. Similarly, mark the points 2 3 4 up to 8 on the line CE and get the points 2 1 3 1 4 1 up to 8 1 and 2 1 dash 3 1 dash 4 1 dash up to 8 1 dash respectively. Join these points by a smooth curve, then we can get a required hyperbola. So this is the procedure to draw the hyperbola. Whenever the eccentricity value is greater than 1, then we can draw a hyperbola curve. Next, we will discuss about the procedure to draw the tangent and normal lines to this hyperbola curve. First, mark point anywhere in the hyperbola P. Next, join the point P and focal point F. Then draw a perpendicular line to FP which will meet the directrix AB at Q. Draw a line P and Q. This is the tangent line to this hyperbola. Through P, draw a line PR which is perpendicular to PQ. This line PR is the normal to hyperbola at P. So this is the procedure to draw the tangent and normal to the hyperbola. Thank you.